the Near Extinction Event. That left only 1,000 human ancestors around 930,000 to 813,000 years ago. Human ancestors faced a catastrophic population collapse that brought them to the brink of extinction. This severe bottleneck reduced the global population of early humans to approximately 1,280 breeding individuals and lasted for an extraordinary 117,000 years. The event eliminated roughly 98.7% of the entire human ancestral population, making it one of the most dramatic near-extinction events in human evolutionary history. The discovery through modern genetics. This ancient catastrophe was uncovered through groundbreaking genetic analysis published in 2023. Researchers from East China Normal University and international collaborators developed a sophisticated computational method called FITCOL, Fast Infinitesimal Time Coalescent Process, to analyze the DNA of 3,154 modern humans from 50 different populations. This innovative approach allowed scientists to peer deep into our genetic past without relying on ancient DNA, which rarely survives beyond 300,000 years. The genetic signature of this bottleneck was hidden in the diversity patterns of present-day human genomes. The remarkably low genetic variation observed in modern humans compared to other species like chimpanzees provided crucial clues about this ancient population crash. The analysis revealed that human ancestors experienced a dramatic reduction from approximately 58,600 to 135,000 breeding individuals down to just 1,280. Survivors. The climatic catastrophe behind the collapse. The timing of this population bottleneck coincides precisely with one of Earth's most severe climate transitions, the Mid-Pleistocene Transition, MPT. This period, spanning roughly 1.25 million to 700,000 years ago, marked a fundamental shift in Earth's climate system. Before the MPT, ice ages followed a relatively predictable 41,000 year cycle. During the transition, these cycles became longer, more intense, and shifted to an erratic 100,000. The specific trigger for the bottleneck appears to be marine isotope stage 22. Marine isotope stage 22, MIS 22, which occurred around 900,000 years ago. This event brought extreme global cooling and widespread aridity across Africa and Eurasia. Deep-sea sediment cores reveal sharp drops in ocean surface temperatures, indicating an episode of severe glaciation that transformed landscapes and decimated food sources. The climate became intensely arid, with prolonged droughts creating hostile conditions for many species, including the early humans who inhabited these regions. Life during the bottleneck. The surviving population of approximately 1,280 individuals would have represented an endangered species by modern conservation standard. These early humans, likely ancestors of Homo heidelbergensis, faced enormous challenges in maintaining genetic diversity and avoiding extinction. The small population size meant they occupied a very localized area and required exceptional social cohesion to survive. Archaeological evidence supports this genetic finding through a notable gap in the fossil record between 950,000 and 650,000 years ago. This chronological gap in hominin remains from both Africa and Eurasia aligns perfectly with the timing of the genetic bottleneck, suggesting that the population crash was so severe it left virtually no trace in the archaeological record. The role of fire in recovery. A critical factor in the eventual recovery of human populations was the mastery of fire control. Evidence suggests that early humans began systematically using fire around 800,000 years ago, coinciding with the end of the bottleneck period. The ability to control fire provided multiple survival advantages: warmth during harsh climatic conditions, protection from predators, cooking to improve food digestion and nutrition, and the ability to extend active hours into darkness. Recent archaeological discoveries show that human ancestors were using fire for tool making and food preparation as early as 800,000 years ago. This technological advancement likely played a crucial role in allowing the surviving population to expand rapidly once climate conditions improved. By 813,000 years ago, the human population had begun its remarkable recovery. Evolution and speciation. The bottleneck event may have been instrumental in human evolution itself. The genetic isolation and severe selection pressure during this period could have accelerated evolutionary changes, potentially leading to the emergence of new hominin species. Some researchers propose that the survivors of this bottleneck evolved into Homo heidelbergensis, which later became the common ancestor of modern humans, Neanderthals, and Denisovans. The extreme reduction in genetic diversity during the bottleneck, followed by rapid population expansion, created conditions favorable for evolutionary innovation. This pattern is consistent with the punctuated equilibrium model of evolution, where periods of stasis are interrupted by rapid evolutionary change during times of environmental stress. Brain. Evolution and cognitive development. Interestingly, the period following the bottleneck coincides with significant increases in brain size among early humans 16th to 17th, 18. The harsh conditions and survival challenges during and after the bottleneck may have selected for enhanced cognitive abilities, problem-solving skills, and social cooperation. The development of larger brains required substantial metabolic investment, but provided crucial advantages for survival in unpredictable environments. Studies of brain evolution in Pleistocene hominins show that the period from 700,000 years ago onward was marked by accelerated brain growth. This encephalization phase corresponds closely with the recovery period following the bottleneck, suggesting that the cognitive demands of survival during this crisis may have driven human brain evolution. The remarkable recovery following the bottleneck, human populations experienced explosive growth. By approximately 83,000 years ago, the number of archaic humans had increased by over 2,000%. This remarkable recovery was facilitated by several factors: improved climate conditions, mastery of fire technology, development of more sophisticated tools, and possibly the evolution of enhanced cognitive abilities that allowed for better adaptation to changing environments. The rapid population expansion after such a severe bottleneck demonstrates the resilience of early human populations and their remarkable ability to adapt to environmental challenges. This recovery laid the foundation for the eventual global spread of human populations and the emergence of modern Homo sapiens. Scientific debate and ongoing research. While the genetic evidence for this ancient bottleneck is compelling, the scientific community continues to debate various aspects of the hypothesis. Some researchers question the precise timing, suggesting the bottleneck may have occurred earlier, around 1 million years AG. Others debate whether climate was the sole cause or whether other factors, such as competition with other hominid species or genetic mutations, played significant roles. Independent studies have begun to confirm aspects of the original research while providing additional insights. Some suggest that the bottleneck coincided with major migrations out of Africa, as early humans sought refuge from deteriorating conditions in their ancestral homeland. The opening of land routes during periods of low sea level may have facilitated these migrations, though the journey was perilous and few survived. Implications for understanding human evolution. This ancient near extinction event fundamentally changes our understanding of human evolution. It demonstrates that our lineage survived not through continuous expansion, but through a series of dramatic contractions and recoveries. The bottleneck explains several puzzling aspects of human genetics, including our relatively low genetic diversity compared to other great apes and the apparent rapid evolution of certain human traits. The event also highlights the profound impact of climate change on human populations throughout history, as modern humans face contemporary climate challenges. This ancient crisis serves as a reminder of both human vulnerability to environmental change and our species' remarkable capacity for adaptation and recovery. The story of how fewer than 1,300 individuals survived one of the most challenging periods in Earth's climate history and went on to populate the entire planet represents one of the most dramatic chapters in the human evolutionary saga. Their survival during this 117,000-year ordeal ultimately made possible the emergence of all subsequent human populations, including our own species, Homo sapiens.